Hello and welcome to this ALINT-PRO tutorial. My name is Brandon and today I'll be showing off the automatic constraints feature available in ALINT-PRO. Now this feature is quite useful in determining where constraints are needed and what constraints need to be modified, as we can generate a list of suggested commands that can then be applied to your project. So to start off here, we can see via our synthesis report that this project is currently unconstrained. To remedy this, we can simply generate our constraints automatically by running our CDC Flow. I'll first show off the options available in the CDC Flow, as it is here we can modify just what constraints will actually be generated. Going through the list here, our first step will be clock setup, and at this stage we can generate constraints for our clock and clock groups by enabling this setting here. If selected, we must also provide a location for the output file which will hold our generated constraints. By default, this will be within the ALINT output/constraints folder of your project directory. And the second option here allows you to set a custom description of that file as well. Moving on to the next stage in the flow, our inputs and output setup phase, we can see similar options for generating constraints for our I/O delays. These will generate those set input delay and set output delay constraints, which can be especially tedious on larger projects, given how many there can be. Once again, we have those same options for selecting the file location as well as custom description. What's new here, however, is the consideration for asynchronous ports generation. We can choose to set a false path, a max delay, or simply do nothing here. Additionally, we have this option here for generating those previously clock setup constraints, basically allowing you to group all your generated constraints into a single file. Finally, we can also see an option here for black box constraint generation, with all of those same options available. Moving on to our final setup phase, we can see our last constraint generation action for resets. And of course, all of those same options are available here as well. So now that we know what can be generated with our CDC flow, let's go ahead and run the flow to check out our suggested constraints for this project. First, however, I just want to show that our project's current ADC file is empty and will remain empty even after the constraint generation, as instead of applying them immediately, as is the case with some chip-level save commands, these generated constraints are meant to be more of a starting point for your constraints, as well as a means of checking where in your design constraints might still be needed. So let's go ahead and check them out now. Opening our generated file, we can see a nicely formatted layout that sections off each type of constraints. We've got clocks, clock groups, I/O, timing path exceptions, as well as resets. Under each section, we have our relevant suggested constraints, and these are suggested by the tool looking at the design layout and checking where constraints are needed or where they are missing. As our project started without any constraints, we have quite a few suggestions that we can add to our project. Going over these constraints, I can choose which ones I want to be applied simply by adding them to my project's constraint file. As I want my constraints to be comprehensive, I'll just go ahead and copy the entire file over. Here, it's particularly nice to have this formatting for different constraints. Now that I have a solid foundation to start fine-tuning these commands, I can go over each command and modify them as needed. For example, as the tool will just use default values for clock periods when frequencies are not explicit, I can go ahead and change these options to the desired values. Once I am done tweaking these commands as needed, I can go ahead and run my flow again to apply them, as they are now included within my project resources. This time, when the tool is looking to generate constraints, it will now see those already applied, and this information will be reflected in that previous output file. As we can see, we now only have existing constraints in this file, and there are no more suggested constraints. We can of course verify this in the synthesis report as well. Overall, this lack of suggested constraints suggests that we have pretty comprehensive constraints within these areas. Of course, this type of check can be applied on projects where you've written your own constraints from scratch, instead of generating them, as running this flow can always show which areas might be lacking, as indicated by the inclusion of suggested constraints. Since we copied over everything here, we don't have any suggested constraints and can therefore consider our current ADC file to be comprehensive. In fact, if you want to run a check like that, or simply generate constraints without having to run the CDC flow, This behavior is available as well through the project.generate.constraints command. Going to our command reference guide from the help menu, we can check out how to use this command. As it is a project command, we will find it under the project directory. Of course, if you have trouble finding it, you can always search for the command by name. Going over the actual command, however, we can see options similar to what was previously generated. There are options for generating existing constraints and suggested constraints, as well as for those different types of constraints, such as clocks, clock groups, I/O delays, and resets. By mix and matching these switches, or simply using one of the combinational arguments, such as this ADC option here, to generate everything, we can build a generated file just like the one we previously saw, all without having to run the design flow at that time. In fact, we even have some additional options here to fine-tune our generated file, such as changing the flavor of the constraints, meaning having them tailored towards other tools other than the default SDC format, as Vivado and Quartus types are available here as well. As an example of this command, I'll just go ahead and run it with the ADC, suggested, and existing switches, which should generate something similar to what we saw via our CDC Flow generated file. Going to the file that I specified in the command, we can see that this is indeed the case. Overall, these generated constraints provide a great foundation for your own project's constraints, as well as help identify where your current constraints might be lacking. This process can be automatic and seamless via the CDC Flow, or convenient in the sense of being ran at any stage in the design via console commands. In any case, be sure to check out automatic constraint generation during your next ALINT-PRO project. And of course, thanks for watching.